The third construction we're going to do is draw a circle through 3 points. So again, Geogebra, go to Geometry, and we're going to randomly pick and draw 3 points on your screen, points A, B, and C. Now, you can put them anywhere you want, but the goal is going to be to make a circle that goes through all 3 points. In other words, I want to find a spot where I can draw a circle so that it touches points A, B, and C at the same time. If you just try to randomly do this, it's hard to get a circle that touches all 3. I get a circle that touches point C down here, but it misses A and B. If I hit point A, it misses B and C. If I hit B, it's really close to A, but it's not hitting C. So if I pick one, I can cheat and try to move the points to be on the circle. The problem with that is, then when I move one of the point I originally selected, it doesn't stay on those. So we're going to have to draw the circle a different way. I'm going to go to Undo to get rid of my circle. Undo a couple times so the circle goes away. And again, I want a circle that goes through all 3 of these points. The way to do that is to connect the points with segments. I'm going to connect points A and B, and then B and C. To find the circle that touches all 3 points, we need the perpendicular bisector of each of these segments. So I need to find the perpendicular bisector, the line that goes through the middle of the segment and makes a right angle. Luckily, on this program, there's a tool that does that for you. It's this one, under More Tools, the Perpendicular Bisector. I'm going to click on points. I'll start with AB. And what happens is I get this new line shows up, and if I move point A or B around, this new line stays halfway between them and always makes a right angle. Now, the picture's getting crowded, so we're going to do something to make it so we can tell which is our created line here. You're going to right-click or Alt-click on that line, go to Settings, and change its color. I'm going to make mine pink. So now, as I move point A around, that pink line always is halfway between A and B, and we're going to see if it always makes a right angle. To do that, I need a point where they touch and another point to measure the angle. So go back, get the point tool, put one point at the intersection of AB and its bisector here, and another point somewhere on AB. Now we're going to measure the angle by going to the measurement tool over here and clicking on points A, D, and E in order. And as I move point A around, we can see that that angle stays 90 degrees. We're going to do the exact same thing for the other segment, segment CB. So go back, perpendicular bisector for CB. Right-click on it, change its color. Again, I'll make it pink. And again, I'm going to put a point where they touch, and another point on that bisector, and measure the angle. So now, no matter what I do to my original points, A, B, and C, the pink lines pass to the middle of each segment, and they make a 90-degree angle. Now, the original idea was to make a circle that touches A, and B, and C. That circle has a center where the 2 pink lines, the perpendicular bisectors, touch. So I'm going to put a point right where they touch, and I grab a circle tool. I can click on the center, and then if I click on point C, you'll notice the circle touches points A and B. If I go to point B, it touches all 3 points. If I go to A, it touches all 3 points. Doesn't matter which one you pick, the circle will hit all 3 points, even if you try to move them. If you grab the points and move them around, the circle will follow and always pass through points A, B, and C. When you get to this point, call your teacher over to check.